Hello, everyone. How are you doing? I trust you're all doing great and the festive season mood has been activated. James from JTS Maths Tutoring here. Today, we just want to prove that if we take the inverse of a given matrix, we will arrive at that original matrix. Let's get going. Suppose A is a 2 by 2 matrix with the entries A, B, C, D and is invertible. Prove that the inverse of A is A. So by definition, we know that if A is a 2 by 2 matrix, so with the entries A, B, C, D, and is invertible, then what I'm highlighting right here, this is the inverse of A. So we want to take the inverse of A and see if we are going to arrive at A. All right, this is where we are right here, okay? So this is going to be 1 over the determinant of the inverse of A. And we know that what happens here is that we swap the position of this entry here and this entry, and we negate this entry here and this entry right here, which is exactly what you see right now. Okay, beautiful. So the determinant here is going to be this entry multiplied by this entry minus this entry multiplied by this entry, which is exactly what you see right here. So you're going to have AD over AD minus B squared minus BC over AD minus B squared, which when simplified is actually just going to give us this, right? You know, this is a fraction where we have a common denominator, so all we simply do is to subtract the numerators. Beautiful. And when we simplify this further, it's just going to give us AD minus BC here. So we are going to multiply this matrix here with this scalar, and it's going to cancel all our AD minus BCs to give us ABCD, which is exactly where we started it. Therefore, we have actually proved that when you take the inverse of A, you're going to arrive at A. All right, and I want you to take note that this actually holds true for all square matrices, not only 2 by 2 matrices. Beautiful. And I also want to let you see something. Why did I highlight this in blue and orange here? Because we know that there is a property which states that the determinant of an inverse is equal to 1 over the determinant of that matrix, meaning that 1 over the determinant of the inverse of A is equal to 1 over the determinant of A, which is just going to give us A. So instead of doing what I did here, I could have just taken advantage of this property, of which we know that this is the determinant of A. Beautiful. Guys, this is all I had for you today. Now you know that taking the inverse of a matrix, it's going to give you the original matrix. Beautiful. Till we meet again, be rest assured that at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Till we meet again, don't do what Mama and I wouldn't do. Adios, amigas and amigos. See you soon.